Yes, I would like to salute everyone who's watching me. So this afternoon or tonight, we are going to look at friction and machines. And we are going to look at the definition of friction, machines, and other things. So at this juncture, I would like to start with friction. What is friction? That's a simple question. Friction is a force that opposes movement between objects which are in contact. As simple as that. I would like to repeat, friction is a force that opposes movement between objects which are in contact. That's what friction is. And we say friction is the force that opposes movement of objects in contact. Briefly, that's what friction is. And we are saying that we have types of friction. We have actually types of frictions whereby we shall have sliding friction, if not rolling friction, at times called rolling friction. Then we shall have static friction, static friction. Then we shall also have what we call viscosity. So basically, these are the three types of friction we have. We have sliding or rolling friction, static friction, and viscosity. What is sliding or rolling friction? This is a type of friction which is found in objects which are in movement or objects which are in motion. Then what is static friction? This is a type of friction which is found in objects which are in one position, objects which are not in movement. Then we say, okay, we also have here what we call viscosity. What is viscosity? Viscosity is a type of friction which is found in air, if not water, or in liquids and gases. This is a type of friction, viscosity, which is found in gases and in liquids. We are done with this. We want to look at the properties of friction. Properties of friction. Properties of friction. What are the properties of friction? Basically, we have actually three properties of friction. One is whenever friction occurs, heat must be produced. Or whenever friction occurs or takes place, heat is produced. So that's one property of friction. Two, friction is greater in actually rough surfaces compared to smooth surfaces. So we say there is actually greater friction in rough surfaces as compared to smooth surfaces. That's another property. The last property is the greater the load, the greater the friction force. The greater the load, the greater the friction force. That if in case you have, like, when you actually have too much load and you're trying to overcome it, there actually friction will be much more as compared. So we say the first property is when friction occurs, heat is produced. Heat is produced. Point two, the greater the load, the greater friction force. The last one is there is more friction on rough surfaces compared to smooth surfaces. So we say these are the properties of friction. Basically, there are three ways. Okay, more are there, but these are the three that so far we know. Say one, friction occurs. When friction occurs, heat is produced. That's the first one. Two, the greater the load, the greater friction force. Then with the last one is there is more friction on rough surfaces as compared to smooth surfaces. So basically, these are the three properties of friction. Leaving that apart, we want to look at how useful friction is, uses or usefulness of friction. How useful is friction? How useful is friction in our day-to-day lives or in day-to-day life? Useful. How useful is the friction force? One, we say it helps one in walking or when walking. Friction helps one in walking. It helps one when walking. It's actually friction that enables you to walk from one place to another. Two, it helps to stop moving objects. It helps to stop moving objects. So this is actually one of the property, one of the usefulness of friction. It actually helps to stop moving. For example, a car. Whenever a car is actually in movement, and someone who's driving it would want to stop, it's just a matter of applying brakes, and then, of course, friction will take place and the vehicle stops. We said the next point, friction enables one to write. It helps one to write. It helps one to write on a paper. To write on a paper, or on a piece of paper. On a piece of paper. Or it even actually, it helps me as a teacher, it helps me to write on this whiteboard using this marker. So I can easily write without finding difficulty because there is friction which is taking place. We also have, it helps when sharpening objects. It helps when sharpening objects, like panga, when someone is sharpening a panga, when someone is sharpening a knife, etc. There are many objects that we can actually sharpen. So as we are sharpening using a file, friction is actually friction will take place, and that friction is the one that will enable this object to become sharp. That's one of the uses of friction. We also have friction enables one to light matchsticks. It helps one to light. It helps one to light matchsticks. So assuming you have a matchbox and matchsticks inside that matchbox, what you do, you strike, but you look at the rough part of that box or that matchbox, and then you strike, but strike gently. So actually, because one of the parts of that box is rough, friction shall take place and will actually enable that matchstick to light. So basically, these are the uses of friction in day-to-day life. How friction is important, and actually, if friction actually would not take place, meaning some of the things would not happen. For example, sharpening of objects, lighting of matchsticks, and then writing on a paper. It would actually be hard for us to write on a piece of paper using a pen or pencil. So basically, those are the uses of friction in day-to-day life. So we want to look at disadvantages of friction. Disadvantages of friction. Disadvantages of friction. Or how friction is a nuisance. How friction is a nuisance. How friction is a nuisance. Disadvantage of friction, or how friction is a nuisance. Meaning, how does it bother you, or how is it a problem? So we want to look at the disadvantage of, much as it has the uses, but also there are some disadvantages of friction. So without much ado, I would like to clean up this side and actually outline for you these points. One, friction produces unwanted heat. Two, friction produces unwanted noise. Friction produces unwanted noise. Three, friction wears objects. Wears objects. E.g., machine engines, we also have shoe soles. So we say friction wears objects, e.g. machine engines. We also have shoe soles that were like, for example, like when you actually have a mini pair of shoes and we continue using them for a long period of time, you realize that your sole will actually become exhausted, or it will actually start doing what? Developing holes. So that's actually friction that caused all that. Then we also have friction produces unnecessary heat or unwanted heat. It's actually very true that whenever like you happen to for example, if you happen to get two metallic objects which have rusted, and you try to rub one against the other, you realize that there is that heat which is produced. Then we also have unnecessary noise. Normally when someone rides like a bike which is not well oiled, you realize that that bike is going to produce that noise which is actually unwanted. So we also have other disadvantages. For example, friction retards work, or you can say friction delays work. So because of too much friction, someone will actually take time, or will take too much time in order to accomplish that piece of work because of this friction. Then the last one, you can also say friction reduces the efficiency of the machine. Reduces the efficiency of the machine. So basically, these are the disadvantages or how friction is a nuisance. One, we said friction produces unwanted heat. Friction produces unwanted noise. Friction wears objects, e.g. machine engines. We have shoe soles. Then we also have friction retards work. We also have friction reduces the efficiency of the machine. Basically, these are the disadvantages or how friction is a nuisance. Leaving that apart, we also would like to look at other things. Yes, we also would like to look at other things. We want to look at how to increase on friction. How to increase on friction. How to increase on friction. So we have ways how we can actually increase on friction, and we also have ways on how we can reduce on friction, depending. So one, how can we reduce on friction? How can we increase on friction? One, by making rough surfaces smooth. By making rough surfaces smooth. Two, by putting spikes on sports boots. Two, by putting threads on car tires by putting threads on car tires. We also have by putting grips, by putting grips on bicycle handles, So these are actually basically the ways how one can do what? Increase on friction. One, by making rough surfaces smooth. Two, by putting spikes on sports boots, by putting threads on car tires, and by putting grips on bicycle handles. So basically, these are the ways how we can increase on friction. We also would like to look at ways on how to reduce on friction. How can we reduce on friction? Or how can we decrease on friction? We also want to look at on how one can reduce on friction. Ways of reducing friction. How to reduce on friction. So we also want to look at ways on how one can reduce on friction. One, you can say by lubricating parts of a machine. When I say lubricating a part of a machine, I mean greasing it or oiling it. So these are ways how one can actually lubricate the part of a machine by applying grease on that part or by applying oil. Of course, oil is a product of petroleum. Then we say we can also have by actually using rollers. We also have this by using rollers. Rollers are like logs of wood. Arranged, and an object is actually placed. For example, let me talk of a boat. So this is a boat. Someone was actually trying to make this, but of course the boat you make it on the shores of the water body. Then, after actually you've already made your boat very well, then you can roll this boat up the water body. Now, these are rollers. Now, these rollers here, they prevent the part of this object from actually reaching where? The ground. And now, if you happen to roll this on the ground or to drag it on the ground, on the bare ground, automatically it will actually get damaged. So that's why we use what? Rollers. 3, by using ball bearings. What are ball bearings? These are round metallic balls that we put on the wheel of the bike, such that it can keep the two moving parts separate. Then we can also say by streamlining bodies of moving objects. Like, for example, you can streamline the body of an airplane, you can streamline the body of a car, you can actually streamline the body of a boat, a canoe. There are very many other objects actually. By making one end a bit sharp, so that it's such that it can actually penetrate, or it can actually do what? Penetrate through that friction, which is known as viscosity, and to overcome it. So basically, these are ways how we can reduce on friction. One, by lubricating parts of a machine. How can we lubricate a part of a machine? By either greasing, if not oiling it. Two, by using rollers. Three, by using ball bearings. Four, by streamlining bodies of moving objects. Basically, these are the ways how one can reduce on friction. Very good. We want to look at machines. We also want to look at machines. And the question is, what is a machine? A machine is a device that simplifies work. A machine is any device that can simplify work. A machine is any device that can simplify work. Or you can say a machine is any tool that can simplify work. Any tool that you can use to do your piece of work. For example, you would want to cut something, or you would want to peel, matoke or banana. So what you do, you can actually choose to use a knife in order to peel that banana, such that you can actually have it without peels. So you can actually use a knife as a machine that actually helped you to simplify. Two, you can say a machine is any tool that can be used to simplify work. A machine is any tool that can be used to simplify work. So you use that tool to do the work. Like, for example, the peeling, for example, cutting pieces of meat, you use a knife to simplify the cutting. We want to look at types of machines. We also want to look at types of machines. Basically, there are two types of machines. We have simple machines. And complex machines. So these are the two types of machines. These are not examples of machines. These are types of machines. Basically, there are two. We have simple machines and complex machines. So someone actually would want to know what's a simple machine or what's a complex machine. We are going to define all this. So we are going to define these two types of machines. We are going to define these two types of machines. We are going to begin with a simple machine. What is a simple machine? That's a question actually I'm actually asking. What is a simple machine? A simple machine is a device which is made up basically, this is actually a definition of a simple machine. A simple machine is a device which is made up of few parts. For example, I can actually have a knife. I can also have here a panga. I can also have a hoe. I can also have a razor blade. And many other examples of simple machines, of which we cannot actually mention them and finish. So basically, these are the examples of simple machines. We have a knife, a panga, hoe, razor blade, and many others. We also want to look at the definition of complex machines. What's a complex machine? That's a very, very cheap question. This is a device which is made up of many parts. Which is made up of many parts. Can actually have an example of that machine. For example, we can have a tractor. We can actually have a sewing machine. We can actually have a vehicle or a car. We can also have what you call an aeroplane and many other examples of complex machines. So basically, these are the examples, but there are many others. So this is a definition. What's a complex machine? This is a device which is made up of many parts. For example, a tractor, when you look at a tractor, it has got very many parts, of which someone actually cannot count and finish. Then we have simple machine. What's a simple machine? This is a device which is made up of few parts. For example, a knife. And for you to use a knife, you don't need training. No one should actually train you on how to use a knife. Yes. And for you to use a hoe, you just have to look at someone using it. Then tomorrow you also pick a hoe and start digging or weeding. So this is actually, these machines or these devices do not have many parts. Whereas the complex machines, they need training. For example, for someone to know how to operate a tractor, you need to go for training before you learn how to operate a tractor. A sewing machine, for you to know how to make a garment or a piece of garment, please, you need to go for training for you to use this machine, of course, to make a garment. Or an aeroplane. For you to know how to fly this, you need to go for training. You need to train you before you start flying an aeroplane. So that's why you call it a complex machine, because it has got many parts of which you need training. You need someone, you need a master to train you. And of course, of course, after that, you will of course be in position to know on how to use these machines here. So we also want to look at other things, leaving that apart. We also want to look at other things. We want to look at classes of machines. We want to look at classes of simple machines. Classes of simple machines. So there are many classes of simple machines. We have actually a number of them, whereby we shall have what you call levers. We shall have what you call pulleys. We shall have what you call wheel and axle. We shall have what you call screws. We shall also have what you call inclined planes. Inclined planes. And we shall also have what you call wedges. So these are classes of what you call simple machines, or you call them groups of simple machines. Classes of simple machines. We have levers, we have pulleys, we have wheel and axle, we have screws, we have inclined planes, and we have wedges. So these are the classes of simple. They are not examples of simple machines. Neither they are examples of complex machines. They are classes of simple machines. These are classes, the groups, the categories. We have the levers, pulleys, wheel and axle, screws, inclined planes, and wedges. Basically, those are the class of simple machines we have. Now we want to actually start with levers. We want to start with levers before we look at these others. So we want to actually begin by defining what a lever is. A lever is a stiff rod which turns at a fixed point called fulcrum. So what's a lever? So someone happens actually ask you a question. You say a lever is a stiff rod which turns at a fixed point, which is called pivot, if not fulcrum. So the pivot or fulcrum is actually fixed. Assuming I have here a diagram of a simple machine. So I have a diagram of actually a simple machine. And I would like to actually identify or to know the fixed point of that machine. The fixed point is this point here. That point is fixed. So actually I will actually call that one a pivot. If not, I'll call it fulcrum. And actually this side will of course have the load, and then this side will actually have the effort. So the effort is that force that you need to overcome the load. And the load is the weight which is supposed to be overcome by the force, which is the effort. So we have the fixed point which is called the fulcrum, which is this one here. So this point is actually not flexible. It's actually called a fulcrum, if not pivot. That's that. We actually want to look at the classes of levers. We also want to look at the classes of levers. Basically, there are three classes of levers, whereby we shall have the first class lever, we shall also have the second class lever, and then the last one is the third class lever. So these are the classes of the levers, or of the lever. There are basically three. One, the first class lever, we have the second class lever, and then the third class lever. So these are the classes, leave alone the classes of simple machines. These are the groups of simple machines, and they're not examples. So now, actually, from these classes of simple machines, we picked levers, and we began actually by saying a lever is a stiff rod which turns at a fixed point, which is called fulcrum. In here, we've gone ahead to look at the classes of levers, whereby we have first class lever, second class lever, and then a third class lever. Now, we want to look at parts of a lever. Let's look at parts of a lever before we give the definition for this. We have the load. The first part is the load. The second part is the effort. And then the last one is the fulcrum, or at times we call it pivot. So actually I'm going to draw a diagram of a simple machine and then label all these parts here, because we want to know where are these parts located on that part of a machine. So I'm going to draw a machine, and then we label all these parts here. Assuming I have here an example of a simple machine, which is a seesaw. Assuming I have a seesaw, we have what you call a seesaw. I have my seesaw here on the whiteboard. Assuming I have my seesaw there, this part in the middle of that seesaw is what you call a pivot. And then that on the left side is called a load, and the one on the right is called an effort. So we have the pivot here, or the fulcrum, we shall have the load here, then the effort. And remember, we've not yet defined, or we've not yet known the meanings of all these parts here. So we are going to actually, first of all, this is just a diagram to show you where we can actually find the pivot, the effort, and the load. So we are going actually to define or to give the meanings of this before we continue with other things. Let's also look at the definitions of the following parts of a lever. One, we have the load. What's the load? The load is the weight of an object to be overcome by the effort. By the effort. So basically that's what the load is. The load is the weight of an object to be overcome by the effort. Now for example, I have my 20 kgs of maize flour or flour, and I would want to lift it up. It's okay. So what I do, I apply the effort. I will use my hands to lift this 20 kgs of flour up. Now the effort is that force I put in or I exert into the machine to overcome this load here. So I said the load is the weight of an object to be overcome by the effort. So let's also define this, the effort. The effort is the force, which is exerted, on the machine to overcome the load. Actually, simply, this is actually a simple or the simplest definition of the effort. Is a force which is exerted on the machine to overcome the load. Then the last one is the fulcrum. What's the fulcrum? Fulcrum is the turning point of the machine. Fulcrum is a turning point of the machine. So these are the definitions of the parts of a lever. So friends, I would like to end there for today or for now. Actually, thank you for watching me, and we can continue from there next time. See you.